All right, everyone. One of the first or second seminars that we had, we asked questions on what would you guys like to learn about that you see in the boiler room that you're not really 100% sure about, and a couple of people said heat timer. So I put together a little presentation on the heat timers that we normally see. Now, on our steam systems and in most of our boiler rooms, you're going to see an MPC Platinum, right? That's the current control that we're normally using. This replaced the MPC Gold. Same style control, did the same work, just looked a little different, right? The technology, just like everything else, moves forward. Just like our phones today, right? They don't look like the phones 10 years ago or 20 years ago, the big flip phones. So everything moves up with technology, right? So this is the current control that you'll see a lot in the boiler room. Now, when we say heat timer is the manufacturer, okay? So, but that's what we normally call the heat control, right? It's going to control the heat and regulate the heat going into that building, depending upon a few variables. Okay? Very important is outdoor temperature, right? Outdoor temperature is a very important variable when making heat or when introducing heat into a building. Can anybody tell me why? Anyone? Why is the outdoor temperature important in sending heat into a building? Key word, the law. The law says when it's below 55 degrees outside, from 6 in the morning to 10 at night, you have to provide 68 degrees in the building. Okay? When it goes below 40 degrees at night, between 10 p.m. and 6 a.m., you have to provide 55 degrees inside the building. Okay? So the heat timer is doing exactly that, right? It's looking at the time, and it's looking at the outdoor temperature. And it's got to look at one other thing. It's very important. The system, right? How does it know when it's full? How does it know when it has enough heat? So that's what the control is going to do. It's going to look at the outdoor temperature first. It's below my 55 degrees after 6 a.m. You know what? Law says I need to make heat. Now it's going to look at what is the system temperature or system pressure in some cases, or down the road, apartment sensors. Where are we at? If I need heat, I'm going to make heat. The heat timer is doing exactly that, okay? So everyone has seen this in the boiler room. If you look at your packets, there's a lot of information there, guys. You're going to see the packet. You know, what you see in your packets, you're going to see on the slides here. I'm not going to read it for you. You guys can all read it on your own, but I'm going to hit on certain points that are very, very important and key to the proper operation of the control. Okay, we'll talk about a little bit of wiring, where to wire what, where the sensors go, and what you can look for in setting it up. Then on our break, we have a makeup heat timer here. If anybody wants to come, play with it, try and change settings and controls, hands-on feeling right here, and I'm with you, and we'll go through it. All right? So on the MPC Platinum, real important, we have to bring 110 volts into it. That's line and neutral, right? That's just going to power the control. Okay, once we power the control, this display screen is going to light up. It's going to go through its test period. It's going to make sure that everything that belongs connected to that control is connected, and then it's going to count down. Once it gets to that point, it's going to say either sensors are open or something is missing, or it's going to say, yeah, everything's ready to go. All right, that's when you first power it up. Real important, system temperature, that's our system sensor. On MPC Platinum, it's at the end of the main. Danny was just talking about the end of the mains on a one-pipe steam system, right? Right at the end of that vent, right before it gets to the water line. We'll see a slide on here too. That's where it needs to go, because it's going to say, okay, by the time that gets to a certain temperature or that pipe at the end of the main gets a certain temperature, our system is just about full. And it's very, very important that that gets mounted in the right spot, because otherwise we're going to have fluctuating heat. Okay? We're either not going to have enough heat when we need it, or we're going to have too much heat when we don't need it. So it's key, very, very important that that sensor go in the right spot. The other sensor is the outdoor sensor. It's right here, out temp. And you can see that on your packets. The outdoor sensor is very important because, like we said, it has to regulate by the law. So it's going to look at what the outdoor temperature is, and it's going to determine, number one, do I need heat? And number two, it's going to determine how much heat do I need. The colder it gets outside, the more heat I need, right? The warmer it is outside, the less heat I need. And the heat timer knows that. And there's an algorithm that it works with, depending upon how cold it is outside, and we're going to get into that. So the two key sensors for this control to operate properly is the system temperature control sensor and the outdoor temperature sensor, and then 110 volts. Two other wires need to get connected to it. Anybody can tell me what they are? The limits. It's going to turn the burner on and off. System's wired. It's ready to go. All it's going to do is turn the burner on and off. It's the burner relay right here. Okay? Remember we talked about last month on a series circuit. Switch is closed, lets the current through. Switch is open, doesn't let the current through, fire the burner. So that all that is just an open closed switch. When it's closed, it's making heat. When it's open, it's not going to make heat. Gets parallel with the aquastat, right? We talked about that. Same limits, so that either the aquastat or the heat timer are going to fire the burner. We don't want the aquastat and the heat timer in series. We want them parallel. We talked about that last month, right? For you guys that were here. Very, very important when it comes to wiring the heat timer and the aquastat. All right, so everyone's comfortable with this front page? One other thing that's important to the settings, this button right here. Everyone see that? That's the adjust and control knob. Real simple. Turn to scroll, push to select. It's just like everyone that has a computer at home. You have your mouse, and you're scrolling around with your mouse, and you push to select it. This is going to do the same thing. You're just going to turn it left or right to scroll down or up, and you're going to push to select that item or that feature that you're scrolling through, okay? On your startup or in your settings. The outdoor sensor. This is the new style sensor that we've been seeing for the last few years. Important, very, very important, that it get mounted on the north side of the building or on a north-facing wall. Okay? A lot of times, the north side of the building might not be accessible, right? There might be another building attached to it on the north side. So what we like to do is go in the courtyard. As long as it's a north-facing wall, that's the proper location for it. Can anyone tell me why? Why does it have to go on the north side of the building as opposed to the south side of the building? Because the sun is going to shine directly on in the south side. Everyone knows sun rises in the east, sets in the west, right? As it comes around, it goes around the south side. Doesn't go around the north side. Okay, so as it rises in the east, comes around the south side during the day, sets in the west. The south side is always going to face sunlight. The sunlight is going to affect the sensor. Okay? Also very important with the outdoor sensor, we want to have it at least, at the very least, 24 inches away from any louvers, any windows, any openings that can skew that temperature. All right, or set it off. It's real important that it doesn't, it measures that outdoor temperature at that time. And there's no fan or louver or halogen light fixture facing right on the sensor. It's going to affect it, okay? And then it will be 50 degrees outside. The sensor might think it's 60. People aren't going to get any heat, and then we're going to have a problem. The other thing that's real important about this, the manufacturer wants it 10 feet above ground. All right, we want it at an optimum height to measure the outdoor temperature. They don't want it up on the roof of a 30-story building. Why? Because it's normally colder up there, right? It might be 10, 15 degrees colder up there than it is down low. Okay. The other thing, when you're putting the sensor outside, if you see this egg, it'll come with, you'll see in the package, it'll come with an adhesive sticker that's shaped exactly like this egg. And if you look on it, it says for outdoor use, when being used as an outdoor sensor. Reason being is Heat-Timer, when they started manufacturing this, they decided we're going to make one sensor that we could sell for 3 different items. I can use it as an outdoor sensor, I can use it as a heating system sensor, and I can also use it as like a well sensor, right? So instead of making a separate sensor for each one, the housing is the same. In the outdoor sensor, if you don't put that adhesive back on there, water can get inside there. It's to keep it somewhat dry so that the water doesn't get inside here and affect this. This sensor works on resistance. And we spoke a little bit about that last month, right? But we didn't get too deep into it. But as the temperature changes, the resistance on this sensor changes. If you put water in between here and here, it's almost like a dead short, right? So it's going to skew the resistance. So it's real important that this stay dry. And that's the reason for that item. A lot of people might look at it, it's a piece of paper, they throw it out. We don't need any stinking directions, right? We know how to do this. But they don't realize on there it says it has to be used on an outdoor sensor, okay? If you don't have it, do we throw the whole thing away? No, we're mechanics. We come up with an idea, get some silicone the back, right? Just, oh, we don't have the outdoor sensor labeled, so we might as well throw it out and call Dwayne for a new one. And Dwayne's gonna say, I already sent it to you. Yeah, but it doesn't have the backing, it's no good. Let's not do that, okay? Think of it. We're mechanics. We can figure it out. All it's doing is sealing that back, okay? Get some silicone, and you can silicone all those holes and seal it. Does the same thing, all right? Very important. When we connect the sensors, it's run with shielded cable between the control and the sensor. The shield does not get connected at the sensor. Okay, the shield only gets connected at the control. Remember the control here? When you look at the control settings, you're going to see a little dot here. Where the dot is, that's where you're going to connect the shield in addition to that other wire that gets connected there. All right, so it's real important, just a key thing. Don't connect the shield at the sensors. All right, you're going to get wrong readings. Also, very, very important, do not run the sensor wire in with current voltage. 110 volts, 24 volts. It's sensor wire. It will affect it, okay? You're gonna get the wrong reading. Remember we talked about last month, electric is heat. As that current runs through that wire, it's getting heated up, or it's letting off some kind of heat. It's going to affect that wire. And it's going to give it the wrong reading, okay? And you're going to see the temperatures on the control start to bounce. Key indication number one when you see the temperatures on the control start to bounce is either the shield is not connected or it's getting interference from somewhere. It could be a ballast, it could be a light fixture, in a light fixture. It could be that the wires run in the same pipe as current voltage, all right? That's a key thing when it gets to these sensors. There's a little picture similar to what Danny was showing you before. And we talked about the sensor at the end of the line. Remember the water line that Danny just showed you? Okay? This is all full. This is the water line of the boiler. Okay? All the returns have water up to that level. It's very, very important that this get mounted on the steam side of that return or at the end of the main, right? Just like Danny talked about. Steam comes up, vents to the main line, gets vented, all the air comes out. As the steam comes in, the air has to come out. Gets to his vent, the vent closes. Now it allows everything to come up to these vents, okay? As the steam pressure comes up in here, the air comes out of here. Once these heat up, they close. That's how we get pressure in the boiler. Right? Once this starts to pressurize, pretty safe to say we should have heat in all this building because all these vents are closing down. So this sensor is going to read a certain temperature. When this pipe gets to, whether it be 150, 160, 170, could be 210 degrees, depending upon the building and how it's vented, is going to determine what that sensor is set at. And we're going to set that when we first start up the control. Okay? How do we do that? We try and start from a cold start. Number one, put the heat timer in manual. That little bypass switch. This is auto and bypass. It's on your handouts there. Put it in bypass. And now we're going to look at that temperature. And someone's going to go all the way to the top floor, furthest radiator in the apartment. And they're going to say, okay, soon as that radiator gets hot, chances are everybody else is hot because this is the furthest down the line. Once that radiator starts to get hot, I know the rest of the building is full. Now I'm going to see what this temperature is. All right? Now I know that that's the setting. It's it's key to the operation of the heat timer. And you're going to see why in the next few slides. Okay? Because the heat timer has to decide, okay, when is the building full? And now, how much heat do I give it? So on every cycle, it's going to fill the steam system, and then it's going to say, okay, how long do I stay on once the system is full? But it has to make sure everybody has heat first. Okay, so that's crucial. Everybody understand that? Pretty simple, right? Piece of cake. Heating system sensor, just like we talked about. The sensor before, the egg, you can use it for 3 different applications. The outdoor gets the plastic coating on the back. On the indoor, it doesn't. What you're going to do is you're going to mount it right to the pipe on a return line, and you're going to strap it around the sensor and the eggshell. But it's very, very important that that sensor, there's a little curve on it, sits on that pipe. You can't just mount the eggshell to the pipe and just throw the sensor in a box. And say, okay, the sensor's mounted. Because it's not going to really get the temperature of that pipe. That's what we're looking to do. So it's important that that sensor get mounted in that groove with the, I want to go back to the sensor here. See in here? And there's a hole here and a hole here. When you're using this as an indoor sensor on a pipe, you're going to put this sensor right inside here. And it's going to sit right on the pipe. That's a hole in the back of the box, on the flat side, on the curved side, exactly. And then the nylon tie is going to come through here, wrap around it, come back through here, wrap around the whole pipe, and then you tie it on. So now it's a good seal, or it's tight onto that pipe. When we use it as an outdoor sensor, we just mount it in this little clip that's provided here, okay? Because now it's outdoor. It's getting the sensor of the outdoor temperature. That's very, very important, all right? You can't do vice versa. As an outdoor temperature, it goes here. Indoor sensor, it goes here, all right? Okay, understanding the cycle. This is the way the system works, and it's important that everyone understand why it works this way. The cycle concept is pretty simple. When we say it's a 60-minute cycle, the 60-minute cycle, or 30-minute cycle, or 90-minute cycle has 2 parts to it. It has an on time, and it has an off time. Obviously, the more heat we need, or the colder it gets outside, the more on time we need. The warmer it is outside, the less on time we need within that cycle period, okay? The cycle period is determined by what type of radiators are in the building. If they're cast iron, like in most of New York City, pre-war buildings, most pre-war buildings, so I say is built before 1940, right? Or before 1930, there's going to be pre-war buildings. They're going to be cast iron. The reason why the cast iron can go for a longer cycle is because the cast iron withholds the heat a lot longer. All right, once the cast iron heats up, it holds the heat a lot longer and can radiate the heat much longer without maintaining that steam pressure in there. Post-war buildings, after the 1940s, 1950s, you're going to see a lot of convectors. What is a convector radiator as opposed to cast iron? Almost looks like a copper tube. And it has the fins in it, exactly. And the fins are made of like aluminum or tin, right? It really looks like a piece of junk or something that you find in a scrapyard, right? It's not the heavy cast iron radiators that you need 4 guys to lift. One guy could take a convector and hold it in his hand and walk down the block with it, right? Or take it right to the scrapyard. Okay. Reason is the convectors don't hold the heat like the cast iron does. So if the building has convector radiators, and you could ask the super, he'll know before you set up your heat timer when you're going through your startup menu, because it's going to ask you what cycle do you want. Do you want a 30-minute, 40-minute? You can set that. Depending upon the radiators, that's the key that you're going to look at. And that's a good starting point. Sometimes later on, Alfred will come down and say, hey, you know, they're overheating. He says, oh, real simple. I'm just going to make it a 40-minute cycle, a 50-minute cycle. And that's great. But the starting point is, let's look at the radiators first, and then we'll set it according to the radiators. And then later on, depending upon how the building works or how it does, then we're going to change it accordingly, all right? By like 10 minutes at a time. All right, so cast iron radiators is a 60-minute cycle. Convectors is a 30-minute cycle. All right? Now, remember we talked about establishing heat, right? Established heat is what period? How do I know I established heat? I just said it, guys. The sensor at the end of the line got to that temperature that we set it at. The last radiator at the end of the line is hot. We're establishing heat, right? We're putting heat into the building. Now that we know heat is established because we reached that temperature that we set it on, we're going to have an on cycle and an off cycle. This is our 60-minute cycle, cast iron radiators, right? Depending upon how cold it is outside, it's going to determine how many minutes it's either going to stay on or turn off. And we're going to get to that. There's a chart. It's in your packet too. And you'll see how many minutes, depending upon how many degrees below the cutoff temperature we're at, all right? So here's a sample. In the milder weather, we're going to establish heat, right? We get to our established heat temperature. Now in the milder weather, it might stay on 8 minutes. Out of that 60 minutes, it may stay on for 8 minutes. Then it's going to turn off for 52 minutes. 52 and 8 is 60 minutes. That's our cycle. The cycle doesn't start until that sensor reaches its temperature. So what happens if we mount the sensor wrong? Or we don't mount it tight enough? And 2 weeks down the line, the nylon tie comes off, or the sensor falls off, or it's not getting the right reading. Can anybody tell me what's going to happen? The boiler's never going to shut off. You're absolutely right. And we're going to overheat the building because it's never going to get to that set point that we already set it at. So you guys who think, it's no big deal, let's just mount the sensor. It's important that the sensor get mounted properly. It's really, really important. All right? Because once that boiler doesn't shut off and everybody starts opening windows and the tenant or the landlord is buying all that fuel to heat the outside, we look bad. All right? And we don't want to look bad because we have a great reputation in the city. We want to maintain that. And it's you guys that are maintaining that, right? So we're going to do it all together. So anyway, we establish heat. We got our 8 minutes, 52 minutes off. Once it's over, it's going to look at the outdoor temperature again. And it's going to say, okay, is the outdoor temperature below 55 degrees if I'm during the day? If it is, I'm going to start another cycle, or I'm going to begin to establish heat again. It's going to establish heat, get to that temperature, and then start all over again. All right? In the instance where we have ICMS, where we have the apartment sensors, not only does it look at the outdoor temperature, if the outdoor temperature is below a certain level, then it's going to look at the apartment sensors. And it's going to say, is the apartment sensors at where we want to be? If it is, then I'm going to wait until that temperature comes back down. And then I'll establish heat. If it's not, then I start another cycle, or I start establishing heat again. Okay? But once it's established, then it starts a cycle. So in this sample for the colder weather, obviously, we might stay on 21 minutes. We might stay off 39 minutes. Right? 39 and 21 is 60 minutes.
Vinny,
Yes?
you have to explain to them, how do you get the 21 minute when the system starts with the cycle?
We're going to go there. We're going to go there. It depends on the outdoor temperature. There's a chart at the end. We're going to go over all that.
I mean, from the data.
It's very important. I understand that. We got the chart. If you look at the packet, we're getting there. Okay, wiring the power, we talked about that. It's very simple. Line and neutral, 110 volts only, guys. Anything more than 110 volts here is going to burn this out. Very important. We ground it. Gets grounded to the box, gets grounded to the trough. The trough gets grounded to the burner cabinet. It's very, very important. These electronics need to be grounded. If they're not, they're going to go haywire. So it's real important. Also, if it doesn't, heat timer voids the warranty. So we want to make sure that every single heat timer that you mount gets grounded. And it has to be a good ground. Okay? If they come in and find that there's a bad ground, they're going to void the warranty. It's very, very important. Okay? We talked about the output wiring for the limits. That's down here, right? Goes to the boiler. It's just 2 wires in series. Switch is closed, fires the boiler, switch is open, turns the boiler off. This can also control a motorized valve. You're going to see it on this side of on the bottom of the heat timer. Motorized valve would need 3 wires. Okay, one is a common, one is open, one is closed. Motorized valve works on a 24-volt circuit in most cases. So you're going to need a 24-volt transformer to provide power to that valve. Okay, here's the simple wiring diagram. Look at it, understand it. If you don't understand it, ask me when you see me in the boiler room. Say, hey, I really don't understand how this works. Pull me to the side. I'll explain it to you. It's real simple. Okay, so it can control a motorized valve, or it can control a burner. Why would we be controlling a motorized valve? In what case? Can anybody tell me where you would see a motorized valve instead of just a boiler control? Hector? Right. What do we call that? Different heating zones. Different heating zones. When you might have a big building, or a building that's set in 4 different buildings or 2 separate sides, and you have one boiler in the middle of the boiler room, but they don't want to heat the whole building because sometimes you have to overheat one side to compensate for the other. You might see a 2-way steam valve for each zone, and then a separate control for each zone. So not only will the heat timer, or each heat timer, turn on the boiler, it also has to open up a motorized valve for its zone that it's controlling. So in some cases, if you see motorized valves, in most cases you're going to see more than one heat timer. Okay? You're going to see 2 separate zones, but one boiler room. All right? If it's just one boiler and it's, a cycled system, you're just going to see 2 wires connected to the burner. That's going to depend on the valve motor. Okay, depends on the VA. Larger size motors, it might be larger than that. So yeah, you're right. It should be a 40 VA, and that's just volt amps. That's just like the current that the motor's going to draw. Remember we talked about overcurrent protection on a 110-volt circuit? VA is the same thing on a transformer. It has to be able to output enough to pull that motor. Think about horsepower in a motor, right? When I have a line starter, I rate that line starter for the amount of horsepower that that motor is going to need, okay? This is the same thing. The VA on a low voltage side is going to depend on what that motor needs to operate, okay, safely, all right? So, yeah, 40 VA is rule of thumb in most cases, but it could be larger than that, depending upon the motor, all right? Does everyone understand that? I know we got off a little bit. Okay. Wiring the system outputs, we talked about that. Wiring an auxiliary clock. The heat timer has a good, cool feature. It has another time clock inside there that you could set to your schedules to just open and close a switch. Sometimes you might see this when there's an electronic ETV valve, where if they want to set back the temperature, I don't want to confuse you on that, but it's just a cool little feature. All it is just another clock within the heat timer that can open and close a switch any time of the day. All right, so in most cases you won't need to concern yourself with it, but know that it's there because you might be able to put two and two together and say, hey, I could do something with that later on, okay? Wiring to the option outputs. The heat timer MPC has 3 separate option outputs where you can have additional outputs for that control, meaning when the heat turns on, it can also close or open another switch. Where might we see that? Where might we see that where I have to turn something else on when I'm making heat? Vacuum system. Vacuum system. I can use the option relay to turn the vacuum system on at the same time that the heat is coming on, okay? I could maybe turn on a pump, all right? It's available. Option 3 relay, we like to keep that separate all the time or not used. In the case of ICMS, they want to use that to turn on and off the modem, all right? That's the internet connection that comes in. So option 3 relay, we try not to use. 1 and 2 are available to us at all times. System sensor, we talked about this before. Here's just a picture of it. So it's 2 wires to the sensor, and then the sensor shield gets connected to where you're going to see the round circle on the control, okay? We don't connect the shield at the sensor, okay? Just at the control. Outdoor sensor, same thing, right? Where it says out temp, outdoor sensor, just 2 wires, real simple. And the shield, which is the bare wire that runs on the outside of the cable, right? Inside the jacket part on the outside of the conductors. It's mounted there.
Why don't they mount it on both sides? I'm curious. I don't know.
What do you mean?
Why don't they say mount it?
It's like a ground.
Shield? It's a what?
It's like a ground. It's like a ground. If anything happens where the wire breaks,
Right.
it's going to know that it's shorted out. All right? It's also going to stabilize the sensor. Hector?
Maybe sometimes on the outdoor or the indoor sensor, I see that instead of having a straight run from the sensor to the heat timer, it has an interrupted wire nut on it, and that would cause interruption or a fluctuation on the reading.
It
It's always good to have a straight run instead of having 2 sections of wire.
It is, and in most cases, what you're going to find is that wire that's spliced down the road, it's in the same raceway as current voltage. It skews it, all right? It throws it off, and you're going to see fluctuating. If you have, and we explained that before, if you ever see fluctuating temperatures, best thing to do is look at the line first off and see if there's any wiring or if it's near a ballast. If you can't solve the problem, you take a wire straight from the control and go right to the sensor, direct run. They recommend that that wire does not go more than 500 feet. All right? If you see that you have to go more than 500 feet, just consult us. And then we'll consult the factory and see what we're going to do. In most cases, we might just have to raise the gauge of that wire, right? Instead of 18 gauge, we'll run 14 gauge. All right, and that'll help it along. All right? Wiring the shutdown. All of these heat timers have a key feature here, and it's just the shutdown mode. All it is a switch that we can put within this, connected to these two terminals. If the switch is closed or made, the unit is in shutdown. It won't activate. A lot of times we use it as a summer-winter switch, right? Because there could be a good chance that we're still in the summertime and the weather goes below 55 degrees, but we're not required to give heat because it's still summer. So instead of the super going through the whole control and start changing settings, we just give them a simple switch. Just a simple toggle switch. If it's closed, the switch is made, it's in shutdown. The control will not turn on for whatever reason. This has to be open in order for it to make, okay? If we don't have a shutdown switch and we want to make sure it's off, what do? Just put a jumper in there. Put a jumper in there. Or you can go into the program and put it in summer. You're right. But if you put a jumper in here, it's not firing. It's going to stay off all the time, okay? You take the jumper out, it's going to fire. As long as it's below 55 degrees. Or 40 degrees at night, depending upon the settings. This is our cycle length table. We talked about this before, and this is what Alfred was talking about. On the control, when you want to set more heat or less heat, all it is just like going down the alphabet. The closer you are to P, the more heat you're going to give the building. The closer you are to A, the less heat you're going to give the building. So it's like setting a thermostat, but you're not setting the temperatures on that thermostat, you're setting the alphabet letters. Okay? So if I want to give more, if I'm on D and I want to give more heat, I can go to E, I can go to F. Okay? That's how it works in its system. And it's pretty simple. Basically what it does is it takes the outdoor temperature proportional to whatever letter I'm on, and it's going to determine what the on-cycle minutes are. Okay? Does everyone understand that? So the colder it gets outside, the longer the and whatever letter I'm set at can make the on-cycle run longer after I established heat, of course, and the off-cycle is going to be shorter. Now, how does this outdoor cutoff minus outdoor temperature get calculated? It's pretty simple. If I have 55-degree cutoff, right, that's during the day, and my temperature is 30 degrees outside, I have what? 25-degree differential. So I look at the column of 25 degrees, right here, and I'm set on F. The on cycle is going to be 12 minutes. What's the off cycle going to be? Depending upon a 60-minute cycle. 48, very good. So it's going to be on for 12 and off for 48 minutes after our cycle, after our steam is already established. Okay, it starts and it's on for 12 minutes. Okay, so now if I change this to 45, what does that do to this? Look at our chart. Look at what it did to here on F. It's 5 minutes. So the warmer it gets outside, the shorter the on cycle. The colder it gets outside, we make this 20. What are we looking at? 35. Look at the 35 column. On F, 19 minutes. It's a whole nother 7 minutes of making heat. Okay? That's the way it's determined. Why does it have to be determined that way? Because remember, at night, we're looking for 40 degrees. Right? At night, we're looking for 40-degree cutoff temperature. What does that do to this? It changes this to 20. So what does it do here? 20 degrees. It's 9 minutes, as opposed to 19 during the day. Right? It's a big change. But we're allowed to do that because we have to cut back the heat at night. Law says we can provide 55 degrees in the apartments, 68 during the day. So during the day we need more heat, nighttime we need a little bit less. That's the reason why it works that way. So understand that it's the difference between whatever the cutoff temperature is, or whatever we set it at, and what the actual temperature is. That's the number you're looking at. You're not looking at what the outdoor temperature is here. You're looking at what it is, what the cutoff is minus the actual temperature. And that's what this chart does, okay? So if I have a 50-degree differential, I'm set at 55 cutoff, and it's 5 degrees outside. It's cold, right? I have a 50-degree difference between my cutoff temperature and my actual temperature. And I'm set on M. It says C, right? C means continuous. The boiler's never going to shut off. It's just going to run constant. In most cases, that's way too much heat, even at 5 degrees outside. Okay? Now, we talked about cycle lengths. On a 20-minute cycle, on a 30-minute cycle, on a 60-minute cycle, or a 90-minute cycle, you look at your chart. At 30 degrees Fahrenheit, and the cutoff is 55, the differential was 25, right? So on a 60-minute cycle, we see on this chart, it's 14 minutes, right here. On a 90-minute cycle, all it is 2/3 of that. Or you divide by 2/3, which is 21 minutes. Okay? On a 30-minute cycle, it'll be half. It'll be 7 minutes. That all makes sense, right? If I'm cutting the cycle time in half, I got to cut the on time in half and the off time in half, right? It makes sense. Any questions on that? This is probably the hardest thing for people to grasp. You know? It's the hardest thing for people to grasp. And it's simple if you just keep it simple. It's the difference between the current temperature, the cutoff temperature, and the actual temperature. All right? Will determine how much heat. So if I have to give somebody more heat, what do I do? Put it in manual. Spoken like a true serviceman. What do I do? People are saying, you know what? No matter what the temperature is outside, we're still not heating enough. It's not staying on long enough. Radiators start to get hot, and then, you know, all of a sudden we have no more heat. And the apartments are cold. What do? We raise the letters. We go closer to P. I like to raise the letters 2 letters at a time. I don't want to go too drastic, because when you get really cold outside, if you see what happens here, say I'm on D, and I have a 50-degree difference, right? I have 25 degrees at D. 25 minutes at D. If I go to F, I got 32 minutes. I'm giving them another 7 minutes when it's 50 degrees outside. If I go all the way down to J, because I want to give them I don't want to get that call anymore, what's going to happen? I'm almost doubling that time. It's too drastic of a change. They're not saying they don't have heat. They're just saying they don't have enough. So let's just raise it 2 letters at a time. All right? Don't go too drastic. Everyone understand that? Okay. Day and night cutoff. To set the day and night cutoff, like we said, the day is 55. The night law is 40. In most buildings that we work in, you might see the day at 58, 59, 60. All right? In the co-ops and condominiums, they can decide whatever temperature they want. If they want to give heat in August, they can give themselves heat in August. All right? So it depends on what the building requires or what they're looking for. So it's always safe to ask the super, what do you want the outdoor temperature set at for day, and what do you want it set at night? Law is 55, but you tell me what you want. Nighttime, same thing. The law is 40, but in most buildings we work in, on the Upper East Side, they're not looking for 40 degrees at night. They're looking for 45, 48, 50. All right? That's not uncommon that you go into a high-rise on the East Side, that they're not looking for 50 degrees at night. Okay? And it also depends on what the occupants of the building are. If there's more young people in the building, they're going to go for 40, 45. There are more older people in the building, depending upon the occupants, they might look for 50. All right? So it's always safer to ask the super first. Don't just assume, oh, Vinny said 55, 40. I don't care what you want. My boss said that's the way it is. That's what I'm going to do. It's not what I'm telling you here. The law says that, but it's up to the building, okay? What are they doing when they're 48 degrees? They're actually changing that cycle time because they're adding 8 more minutes or 8 more degrees, not minutes, 8 more degrees to that calculation, right? Everyone get that? System set point, same thing. Remember, we turn to scroll and we push to select. So we go to 140 degrees or we set it at whatever temperature whenever the radiator got hot. We get to that set point and we push to select. If you don't push to select, you didn't set it. Okay? The page will kick back and show you that it's set at 140 or 150 or whatever the set point is. System sensor differential. I'm not going to read all of this for you. It's in the book, in the packet. You can understand it. All that is exactly what it's saying. It's a differential. It looks at that sensor at the end of the line, and before it starts to establish heat again, because our 60 minutes is up and the off cycle is over, it's going to say, and whatever I set it at, I could set this at 40 degrees. I want to make sure that it doesn't start another cycle unless that temperature on the end of the line goes below that 40 or 25 degrees. Okay? It's just going to wait for that temperature to come back down. Some buildings might not want that. In most cases, 25 degrees is the default setting. It's a good place to start. All right? It's just a key feature. District steam delay. This is a really cool feature, and it's important for a couple of reasons. If I have a boiler that I'm turning on and off, right, then I can determine what the temperature is on the end of the line. If I'm opening, closing a motorized valve, when there's district steam, right, everybody knows what district steam is, right? It's coming from the city. There's no boiler in the boiler room. There is no boiler room. There's no chimney up the building. The steam is coming from underground, from Con Edison, and it's being supplied to the building. And there's an actual meter that's rotating and measuring the amount of steam that's being introduced into that building, and the people are paying for that steam. But now I have to control that steam, right? So our motorized valve, another place you're going to see a motorized valve connected to an MPC, not just a zone, but in a district steam condition, right? It has to open the valve when I need heat and close the valve when I'm done. Because it's district steam, the system tends to stay more hot. We can use a heating system sensor, but they find it's better that we just time it. Reason being is, remember, when the boiler turns on, it's not hot yet. There's no steam in the system. It has to come up to a certain temperature before it starts building steam. So I have to establish heat, right, with that boiler by turning it on, and I have to build pressure. With district steam, the pressure's right behind the valve. I don't need all that time to establish heat. All I have to do is open the valve, and I got steam going into the system right away. All right? So right at the head of that valve, the steam is always there. When you have a boiler, that's not the case. You have to actually turn the boiler on and generate that steam. So that might vary District Steam, it doesn't. So what this does is you can set it at a certain amount of time. And you're going to say, okay, how long is it going to take to establish heat or get heat to the end of the line after I open the valve? The default setting is 15 minutes. All right, that's what it comes set at the factory. So it's going to open the valve for 15 minutes, right? After that 15 minutes is up, what does it do? Can anybody tell me? It doesn't close. If you're saying close, you're wrong. It's just like the heat establish. It starts my cycle, my 60-minute cycle, or my 30-minute cycle, or my 90-minute cycle. After that 15 minutes is up, depending upon the outdoor temperature and whatever letter I'm set on, it's going to determine how long that valve continues to stay open, and then how long it's going to close after that 15 minutes is up. So that 15 minutes is done all the time. Now, seeing that I have this feature on this control, next time I go for a service call and I find out that that system sensor is done, it's broken, the system sensor is no good, we can't give the people heat because the system sensor is no good, what can I do? An option is put it into District Steam for overnight. Set it at 15 minutes, set it at 20 minutes. It's going to cycle, it's going to establish heat. You could turn the boiler on in manual, see how long it takes for it to actually build pressure. It's just a quick fix. It's a Band-Aid until I can get a sensor. Unless you have a sensor in the truck, then you change the sensor right away. But it's an option. You don't have a sensor. What do? We leave the people out heat, or we leave them with too much heat? No. Put them on District Steam. Put it on 10 minutes, and explain to the super. If you need a little bit more heat, you could just raise the letter, lower the letter. We'll be back tomorrow. We'll be back, as soon as I can get a sensor. All right? It could be 3 o'clock in the morning. You don't know what to do. Sensor's bad. What do I do? Put it in District Steam. It'll work the same. Not as efficiently, but it'll work. Quick fix. You wanted to say something? Alex? Oh. Am I over? I'm over. All right, I'm getting a hook, guys. I could talk all night.
You do a good job at it.
There's boost, there's vari boost. I'm just going to real quick. That's because we're cutting the heat back so much at night. In the morning, there's a variable. It'll look at the outdoor temperature or the difference between the temperature between day and night, and it'll say, okay, I got to stay on just a little bit longer in the morning, and it's adjustable to bring that building back up to temperature during the day, okay? Read it. If you don't understand it, I'll explain it to you, okay? And I'm just going to brush through it real quick because there's a couple items. Early shutdown curves and the boost curves. These are the charts that you can look at, okay? The duration of the morning boost is going to depend on whatever the setting is, okay? And what the temperature difference is between day and night, okay? Early shutdown is the same thing. On the way up, we need more heat. On the way down, we might need less heat. So there's a chart that'll determine we could do early shutdown. Instead of shutting down at 10 o'clock, we know it's going to get a little cold, but it's still mild out. We might shut down at 9 o'clock. It has that feature, which could be disabled. All right? You don't have to use it. It's just an item, a feature that it has, and it's pretty cool. System run-on. Remember we talked about the vacuum system. We would use this relay to connect the vacuum system on. Why? Because after I make heat, I still have to keep that vacuum running. And I can determine however long I make it run. System run-on is only for that system relay. And you set it, in most cases, 10 minutes. After the heat is done and the boiler shuts off and the heat timer is done, it's going to stay on for 10 more minutes and maintain that vacuum pressure just to get all the condensate back to the makeup feed tank. Thermal lockout, that's the differential that we talked about for the heating system sensor. Its default setting is 25 degrees. We can either turn that on or off. That's all the feature there. It's either on or off. If it's on, you use it. If it's off, you don't set it, okay? This is the schedule settings. Remember we talked about 6 a.m. to 10 p.m. The feature has, the control has the feature that you could set 4 different day and night per day. In most cases, you're only going to have one setting. 6 a.m. in the morning till 10 p.m. at night, okay? But you do have the option Friday, Saturday, and Sunday. They might want to do 8 a.m. in the morning, depending upon the building. Let them play with that. We're going to set it at 6 to 10, all right? We're safe. But if they want help setting it, we can help them set it, all right? But in most cases, that's what you're going to see. You're going to see 6 to 10, all right? What you want to make sure, though, you're on the control, and you'll see it up here. There's a day button. It'll scroll through the days. Just make sure each day is on. You have to make sure, just because Monday says 6 to 10, doesn't mean Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday is set. Just go through the days and make sure they're set, okay? Any questions? It's got to be at least a question. One. Go ahead.
Regarding the district scheme, how that building is piped? Is it piped the same way as a regular building that has water, regarding as far as the return lines is concerned, or no?
It's a better question for Danny, but yeah, he's right. On the steam distribution is what it is. In most cases on the district steam, you're going to see a vacuum system, you're going to see a two-pipe system. And you're going to see steam traps at the end of the radiators and at the end of every main. And it's going to come back into a vacuum pump. That vacuum pump is going to take that water, technically send it through a heat exchanger because they can't dump 180-degree water. It's going to cool that water off, make domestic hot water with it, and then dump it, all right? So on a district steam system, you're going to see steam come in and water go out into the sewer, all right? But they have to cool that water off, all right? Very good question. Any other, Hector, what do you got?
Vinny, the heat timer is preset at 150 degrees. Sometimes you would bring the knob, whether it's day or night, you'll bring it all the way sometimes halfway, and you're still not satisfied. Sometimes because it's preset at 150 doesn't mean you have to leave it there. Sometimes you can bring it up, and then the day and the night you can bring it down and you get better heat out.
The default setting is 150.
Yes.
But every building is different. And the key thing is to setting it up properly. It's going to take the same amount of time because it's going to take the building, depending upon its piping, the same amount of time to vent the air out, right? Or up to that temperature. So you have to set it properly. You got to make sure you go to the end of the line and that radiator get hot. Once that radiator gets hot, that's the temperature, whatever the temperature reading is. Nobody could say it's 150, 160, 170, 180. We've been to buildings where we've seen them at 190, 195. And I've been to buildings that 140 is way too much. It depends on the building. And the key thing is, like Danny said, it depends on the venting, all right? How well the building is vented. The better it's vented, I'm telling you, the lower that temperature is going to be. The worse it's vented, and it's not vented properly, the higher that temperature is going to be. Guaranteed.
Or he may have a steam leak, maybe not in the boiler room, sometimes.
Or a clogged return. If the distribution system is working right, it's going to get set right. It depends on the building. It all depends on the building, all right? Any other questions, guys, on heat timer? You might see SRC, you might see HWR. MPC is steam, okay? SRC is also steam, but that's with a vacuum system and a motorized valve. Whenever you see an SRC panel, okay, SRC Platinum. HWR is hot water reset control. It's not a steam system, it's hot water circulation. It regulates the temperature of that water going out, okay? And then you're going to see multi-mod. We have one up here. That's a staging control. When I have more than one boiler, and it's a lead lag, it actually sequences the stages. Maybe boiler A might come on first today, boiler B might come on first tomorrow, and then it's going to modulate the boilers depending upon the heat. All right? Any other questions? On a lead lag time, exactly. That's the multi-mod. All right, guys, I'm done. Let me
Guys, want to take a 10-minute break, all right?